Hi, I'm Neil Katz for the Weather Channel, and this is the Climate Corner office. With us today is Beth Heider. She's the former chair of the U.S. Green Building Council. She's been recognized as one of the 10 most powerful women in sustainability. She laughs when I say that, and currently serves as the Chief Sustainability Officer for the U.S. division of Skanska, a massive global construction firm with about $20 billion a year in revenue. Welcome to the Corner.
Thank you, Neil. It's great to be here.
Thank you so much. So tell us a little bit about the firm. Give us a sense of its global footprint and what it does for a living.
Sure. Well, Skanska is a really large construction and development company, so we also develop buildings and then we build them. We build both vertical construction, so buildings, and we build all kinds of horizontal construction or civil works like bridges and roadways. So we have a pretty broad spectrum of things that we build. We don't build single-family houses. We build multifamily residences, but a pretty broad portfolio. Mm-hmm. And here in the U.S. and globally, we've had a long-time commitment to building greener buildings because we think that that delivers better solutions to build for a better society. Now,
you are an architect by trade.
That's correct. Guilty as charged.
But you have an early passion for science and green, and how did that come about for you?
Well, I couldn't avoid it, Neil, when I was growing up because my mom was an earth science teacher. So it just made sense to me when the building industry really started to embrace green building as an architect that all of that annoying training when I was coming along as a kid actually came together around this new movement.
And how early is this movement? When did green building and green architecture start to emerge, and how quickly has it ramped up?
Well, I would say, even back to the 70s, after the first oil crisis, we were starting to look at low energy buildings, and we were looking at building greener buildings, but the early days, a lot of those buildings were sort of the architectural equivalent of Birkenstock sandals, right? They weren't really too attractive, and then when the price of oil came down, it was quiet for a long time. And then I would say that the interest reignited once again in the 90s. And for me, in 1996, the federal government was seeking to figure out ways to build better buildings for their portfolio. And so they were interested in trying to figure out how to green the federal workplace. And so we did a cost analysis with a bunch of really smart people who were doing the design part of that, just try and figure out what features would be considered green and what the cost would be to do that so the federal government could commit that amount of investment to build better buildings for the life cycle. And from there, the lead rating system, the U.S. Green Building Council was founded in 1993. The Leadership in Energy and Environmental Design rating system was rolled out around 2000. And that was really cool because here we were in 1996 or so talking about a green building. Well, we were trying to figure out what a green building was in order to price it, right? Mm-hmm. But the lead rating system not only identified ways that you could green a building, but it provided an entire lexicon. So it's more than the certification, it's actually driving us to have tools that we can use to talk about what we're doing and then celebrate the good stuff that we're doing.
So when this movement started, or this idea started in architecture, was it about climate change, or was it about other kinds of sustainability issues? What did green mean then, and how's it moved?
I would say that early days it was probably more about environment. Mm-hmm. So it's leadership in energy and environmental design, and also energy. And energy is a natural way to sort of take a look at conserving, because now you're not only conserving energy, which is good for the environment, but you're also conserving cost. Sure. So I would say early days, a lot of it was around trying to figure out what the low-hanging fruit was, where you could easily justify building smarter buildings because they would pay back in a short period of time through energy savings. Mm-hmm. I would say that that's sort of where it started out.
Right, so it started as a savings plan or an efficiency idea.
Yes,
more so than an attempt to, fix a burning planet.
Yes, exactly.
Okay.
Well, I would say that there were a lot of people that were out in front who were already, making the clarion call. I mean, all the way back to 1970 when my mother was involved in the first Earth Day movement, and she had her kids out there, talking about we need to do things that are more environmentally responsible.
Right.
And there were lots of visionaries all along the way that were saying, hello, wake up, we need to do something. But I don't think that there was the public awareness about even the connection between green building and climate,
right.
In terms of the general population.
Right, and people in the 60s were more focused on the potential dangers of nuclear power,
Exactly.
or in toxins in our water,
Exactly.
Acid rain. So climate change kind of came along much later as the primary concern for many people. Tell me about the industry, the building industry as a whole. What role does it play in the carbon emission picture, and what does it need to do?
I think, a lot of people, when you talk about emissions, everybody has to get their car inspected, right? And so you think cars emit. We know that cars emit. And you think of industry because you see smokestacks and you see the smoke or the particulate matter and the carbon coming out of the smokestacks. But actually, when it comes to carbon, when it comes to emissions, when it comes to pollution, buildings are actually the bad boys on the block. We emit, and I say we because I own this as an industry, about 39% of all global emissions, that comes from buildings. So that's a problem, but it also creates an incredible opportunity.
Why is it so big? What's in the construction of a building, or the materials of a building, or the maintenance of a building? That's a very high number. Unpack it. What's going on?
Starting from the beginning where the industry started, energy efficiency. So buildings use a lot of electricity, they use a lot of fossil fuel in order to heat and cool and power up all the plug-in devices that we have today, heat your hot water. Actually, electricity, there's a lot of electricity that's used to purify water and to transport water. And all of that stuff serves the building. Those are like your utility bills. Mm-hmm. And in early days, we were really seeking to figure out ways to reduce the utility use. So the next step would be to insulate buildings. This is why you insulate your roof and the walls of your building, and you pay attention to what kind of windows you have. But now, and I think this is also the next sort of part of green building, is you need to be really careful about the kind of materials that you put in the building. Because do you know how it sort of smells after you paint your house? Inside you get that smell.
Chemically smell.
That it's chemicals, right?
Yeah.
It's volatile organic compounds that's not good for you. And that has to do with health. The well building movement, the International Well Building Institute, for example, is really focusing on a language to talk about that. In terms of energy or carbon, you have operational carbon, which is all those utility bills that we've tried to reduce through better insulated buildings. But then you also have the materials that go into the building. So the concrete that makes the foundations of your building, the steel or concrete that is the superstructure of your building, drywall, all of these things.
Cement's a huge issue here, right?
It's a huge, cement in particular is a challenge because it's 6% of global emissions alone. So of that 39%.
And you never think about it. Most people, it's just sitting under your feet. You'd never consider it. Right?
Exactly, but it takes a lot of energy to create the cement. Because you have to heat limestone up, and that takes a lot of energy to convert limestone into cement. And then you've got aggregate, you've got all the stones that are in there, and all of that stuff is heavy, and then you have to transport it. Yeah. So these are all of the dimensions of things that you need to understand in terms of the embodied carbon. So that's the carbon that happens during the extraction, the fabrication, and the transportation and then erection of all of these materials that create the built environment.
So is there anything around the corner in terms of innovation, in terms of the materials revolution? Is there a new cement coming? What's next for that part of the industry?
Well, there's lots of innovation. I think that's the good news. I mean, there's innovation around the materials that are available on the market now, but there's also innovation in terms of how we ask for lower carbon materials. Mm-hmm. So Skanska is really excited to have co-created with the Carbon Leadership Forum out of the University of Washington a new tool that's called the EC3 tool, which is important
Catchy.
Because the name is a mouthful. It's the Embodied Carbon in Construction Calculator.
Less
right?
catchy.
Yeah, much
Worse.
less catchy. What it does is it allows project teams to make better choices about what kind of concrete they're going to put into a building.
So there are choices.
There are absolutely choices.
An energy efficient or carbon efficient version of cement or steel or other big materials.
Yeah, and there's also the mix, you know, sort of like you think about making a cake. There are different combinations of the same ingredients that you can pull together, and then mixtures that cause concrete to cure faster and have special strength and that sort of thing. And what we found on a really large project that we're working on on the West Coast, that just by engaging in a dialogue with the suppliers, they've been able to cut 30% out of the carbon out of the concrete in that project, just by asking. And how do you do that, right? I see you sort of looking at me like, this
30
is
a
like
good number. How do you do it?
Magic.
Yeah.
So if you use a lower strength concrete, for some things, for sidewalks, you don't need a really high strength concrete. For really complicated structures, you need a very high strength concrete. If you're doing low strength concrete, it takes longer to cure, but it uses a whole lot less cement. So that's much lower carbon. And for many
without any new technology, without any fancy ideas,
no,
it's sort of sitting in front of you.
It's just, how are you going to make the cake?
Right.
What are you going to choose to put together? And picking the right strength of concrete or the right mix for the job. Sometimes it's easier to do a batch of high strength concrete or just have that all going out to the site, because then you don't have to be quite so careful, but there's a carbon cost for doing that.
That was never in the calculus before.
No, because it wasn't something that people were asking for.
So tell me about net zero building. What is a net zero building? Explain that to our audience, and how does it work?
So a net zero building is a building that actually produces as much energy as it uses. And what you want to do when you're creating a net zero building, didn't your mother ever tell you that you should always eat your conservation vegetables before you get your photovoltaic cookies?
That was not happening in my house.
Yeah,
no.
well,
that was your house.
That was my house. That was my house.
So
the idea is that you first of all you create a really efficient building.
Okay.
And then you put either photovoltaic panels, or you rely on wind energy, or you offset that by purchasing wind power or offsets, PV panels, and together you've reduced the demand, and then you're creating the energy that is necessary for running the building. And we've worked on some projects. We've worked on a really cool job called the Brock Center. And the Brock Center is a science education center. My mother would have just loved that place. It actually produces almost 180% of the energy that it needs. And then it can push that back into the grid. So buildings can actually be energy generators too, in the right circumstances.
So buildings of the future become power plants.
Exactly.
Very interesting. So what percentage of buildings are that way today?
Oh, now less than 1%. Less than 1%. So we've got a lot of work to do. And, Neil, one of the big challenges is that it's easier to do that right now with the technology in a low density space. So in a suburban neighborhood, it's easier to do it because the relationship between the amount of square footage you have in your house and the surface area that you have on your roof, you can get enough solar power from your roof to run your house.
Right.
But in New York City,
we have a very small roof and a very tall building.
Exactly. We have a geometry problem.
Yeah, so what do you do?
Well, there are a number of things that have been done, and you can, for example, take advantage of the soil below a building and do geothermal piles, which are very efficient in terms of allowing your heating and air conditioning system to, essentially when you cool a building, you don't actually make it cold, you pull the heat out of the air. And that heat has to go somewhere. So you can put piles down into the earth and you can eject the heat into the earth. And then the systems that we have, you can reverse. So you can either use it to heat or cool a building, like a heat pump. But it's really efficient to use the ground, so geothermal piles.
Can you do that in a place like New York City where you don't really control the earth beneath you? I mean, there's layers of
that's true. Geothermal piles are a little challenging. You don't want to hit the subway, right? But I mean, again, this is one of the interesting things I think about our industry and then our country is that unlike my friends across the pond who are all in a fairly cold, dry climate, here in the US, we've got it all. Yeah. We've got, cold, we've got wet, we've got humid, we've got dry.
You've got hurricanes, and you've got tornadoes, and you've got fires.
Exactly. Well, and so, Neil, I think that it's also really important to make this connection between climate change, buildings, and weather, right? So the weather is being influenced, and you can talk about this better than I can, based on a whole variety of things. But one of the things that's influencing the weather is all of this pollution, all of this carbon that we're putting up into the atmosphere. And so I think that a lot of people have a really visceral relationship with the weather. When your basement gets flooded, right, that makes a lot of sense. But buildings are part of what is creating the conditions that cause that weather to happen.
Yeah, and they're hard to change. I mean, buildings last a long time.
Exactly.
Right? These are not very flexible constructions.
My husband likes the notion of getting a new car every 5 years.
Right.
I'm good at 10, but buildings last for generations.
Yeah.
So the decisions that we make today will have an impact probably beyond our children's children. So we need to start making really smart decisions now.
So let's talk about that generational ambition for the building industry. The UN has called for all new construction to be net zero by 2030, for all buildings to be retrofitted by 2050. We're at less than 1% today. How big is that challenge? How do you actually get there?
It's a huge challenge. I think that the first step along the way is education. The conversation that we're having now, I think, is really important. First of all, to say that it's a big challenge, but that we have identified tools and technologies that can get us there. We also need to recognize that some of these solutions will require an investment, and that investment will need to be prioritized. Whenever you move into a new house, you decide how you're going to spend your money. Do you pick a house with a big kitchen? Do you pick a house that has a lot of square footage so that you have, an extra playroom for the kids?
Right.
You make choices. So we're going to need to make choices around choosing lower carbon materials, which at least up front will require an investment because the entire supply chain is not yet set up to do it.
Right.
And we're going to have to decide that we want to make sure that our buildings are insulated properly and that we have smart mechanical and electrical systems in those buildings. And then, if you build a Prius then, right, the building equivalent of a Prius,
right,
but you drive it like a Maserati, you're not going to get great fuel efficiency.
Right.
So that's awareness, that's occupant behavior. And so we have a really great opportunity. We have a role to play in terms of what our expectations are of our houses.
I think one of the things you're describing to me is a market problem where new buildings that are net zero are going to be more expensive than the buildings we have today. There's only a couple ways you can get there. Either the government regulates the kind of standards we need for net zero, or there's enough market demand like there is for organic food, people are willing to pay a premium. I haven't heard people willing to pay a lot of premium on their apartments today or their office space to save the world. Do you think regulation's needed? If so, how does it play out?
I think that it's a combination. It's an all of the above sort of solution. We're going to need regulation and legislation, policy that has teeth in it, to create an elevated playing field so that everybody is competing in terms of building and selling buildings at the same elevation. Industry, though, also has an opportunity to lead, and we've already seen that, where despite the fact that we don't have national regulations, industry has come along and said, we're going to build more energy efficient cars, fuel efficient cars, because we see that that's the future and that's the direction that we are collectively going. And industry has come up with a whole variety of solutions. We were just speaking with some folks from Lafarge, a major cement and concrete company. They have low carbon concrete, but there hasn't been the demand for it, either from the design side or from the customer side. So I think that between legislation empowering the investment in at least initially somewhat more expensive materials, we can get there.
When people talk about climate change in business, they often talk about risk or destruction of value. It seems to me like there's tremendous opportunity for growth in the construction industry because there's a lot of new building we need to do that's up to new standards. How big is the opportunity for your industry?
Whenever there's risk, there's opportunity. And actually, the construction industry doesn't avoid risk. They just want to be appropriately rewarded for taking that risk on. I would say that if you look at the entire sort of portfolio of buildings globally, projections have indicated that by 2050, we're going to build another same volume of that. You know, we're going to double the number of buildings that are in the world. Mm-hmm. So that is going to happen regardless. So the buildings that we're building need to be smarter, or we're going to, multiply the problem. In terms of existing buildings, every year we build about 1% new construction, at least in the United States. That means that some 99%, 99% of buildings already exist. And we need to address the renovation of these buildings as well. Now, that seems like a whole lot, but when you think about it, I mean, your water heater doesn't last forever. Mm-hmm. I've replaced my water heater. We've lived in our house a long time, so we've replaced it twice. There are moments in time over the life of a building when you naturally have to renovate. You're already going to have to do something. So the challenge is going to be to make sure that we make it reasonably cost effective to replace that water heater or replace that heating and air conditioning system with one that is significantly more efficient. And that we also identify new ways of financing things so that you can afford to make those upgrades.
Let's talk about urban defense. People usually call this adaptation.
Yes.
I don't like that word. I think if we call it urban defense, maybe people have a stronger opinion about it. Mm-hmm. But essentially, people have made some predictions that to defend our coastal cities in America alone, the cost could be as much as $400 billion over the next few decades. That's a very big bill to taxpayers. But the other side of that is that's a large amount of business for firms like yours. So are you in that business today, and how do you see advancing it?
Yes, well, certainly. I mean, after any weather disaster, we find opportunities to go back in and rebuild. For example, the Rockaway Boardwalk after Hurricane Sandy hit was obliterated. And we built it back better, higher, and we also built it in phases so that the businesses along the boardwalk could come online. One of the coolest things that I think is happening here in New York is the Big U. So the whole bottom section of Manhattan has a design underway to identify or to build barriers essentially that will prevent the entire bottom half of Manhattan from flooding like it did with Sandy. They've looked at ways to incorporate parks and seating areas and provide a public amenity there as well. You can come up with solutions that actually provide social benefits as well. Mm-hmm. And I think we need to be open to that.
It's an interesting point you make, and it makes me think about what some people are concerned about here, which might be an inequality coming in which cities we defend and which we don't, where we build these beautiful places you're talking about, seawalls with gorgeous parks, and where we don't. Does your firm think about these issues, or is it more focused on where there's a contract, we enter the space and build?
Well, I think design and construction perhaps can be seen as a transactional relationship. You bring me a building, I build it. Certainly what we know is that we need to engage with the market, again, through tools that we've developed so that we can build better buildings. And we also know that we need to have a conversation with policymakers so that they are asking us to build better buildings. We've worked extensively with the U.S. Green Building Council, for example, to help them influence policy around a system that we understand so that we can deliver LEED buildings. And it requires that kind of proactive engagement so that further down the pipeline, we know that the buildings that are being conceived will then be designed so that by the time we come on board, preferably really early in the design phase, so we can start talking about how we need to talk to our suppliers to get lower carbon concrete or lower carbon steel, or identifying ways that we can change the construction schedule so that we can use different materials that have a schedule impact. It takes that entire process from policy to conception to design, all the way through construction and then operation.
What keeps you up at night?
The urgency of addressing carbon in both operational carbon and embodied carbon, because over the life of a building, it's about 50-50. All of that embodied carbon, when you build a building, that's all been expended. Right. So today, for the next 10 years, I would say, embodied carbon is something we really need to get our act together on, because it's going to be very disruptive, perhaps disruption with lots of opportunity, but it's going to be disruptive all along the entire supply chain. The supply chain just isn't built for that. It took us almost 20 years really focusing on operational efficiency, and we've gotten to the point now where our buildings are much more efficient, but we're not there yet either. We're not to net zero. So it's the urgency of this, and I think sort of the sense that we're dancing while Rome is burning. We need to get on with it, and we need to embrace it and really activate the market to deliver on it now.
Do we have a shot?
Absolutely, we have a shot. We put a man on the moon. We need an Earth shot, Neil.
Well said. Thank you very much. I appreciate it. Thanks for coming to the corner.
My pleasure.